Okay, here's the progress of our tough repair. First, the tune switch. Unfortunately, it was broken into 3 parts, and one of the parts was holding one of these legs. We have 3 legs here, so it fell down, and we had to fix it like this using some glue and little bit of creativity for fixing it and holding it firm in place. As you can see, we put some solder here and here in a wire to hold it in place, and also from this side, in addition to winding some wires on the corners with solder, okay, to hold it down like this. All right, and it's working. It took me so much time. This was the most tough. Number 2, the PVC. It becomes actually new, so now we have the confidence to put it on the on the radio, and it will work. Number 3, we have the RF coils. Right, there was a problem, and we changed the old one. This is the EM RF coil, and this is the shortwave RF coil, and we already made sure that it is connected correctly, because the previous one, it has some cuts in it. It's not working. And there is also some important notice that I really would like to talk about. As you can see here, this is the normal connection of normal radios, alright, or nowadays radios, where the RF coil, the white part, is connected to one side or to the RF capacitor, okay, while the other side is colored black and is connected to the common, or in this case, the negative battery, or the negative. It is the common, it is the earth, okay. In Panasonic, though, they are doing some changes. They put the white color of the coil connected to the RF capacitor, and that's okay. But they are coloring the one connected to here with red, indicating positive, because it is connected to the positive, because they use the positive as common, not the negative. So this is very important. Anybody who doesn't know this information will find himself in trouble, because look at the black color now. Do not put it to the ground or to the negative, right? Otherwise, you won't be able to connect the RF coils for the Panasonic. If you don't know, this is a problem. Maybe this is a little bit clear. You can see here in this drawing, this is normal RF coil. L1, or the longest one, alright, it has the white color connected to the PVC, to the capacitor of the RF, right? And the other part is connected to the earth, or the common. This is the L1, or the primary coil. The secondary coil, though, it is starting with red, which goes to positive with some resistance and so forth, and the last end of it, the secondary L2, the last, or the end of it, it is connected to the transistor base, the base of the transistor. But in Panasonic, the situation is different. First of all, they are putting the long wire, or L1, heating to inside, and instead of heating outside. This is the long wire. Look here, the long wire is inside, and the secondary is outside, because they are using this one here. This is the end of the start of L1. This goes to the RF, no problem. And this one goes to the common, which is positive in the case of Panasonic radio. This one, no problem. It goes to the transistor base, and this one goes to whatever it was. But there is a problem. Sometimes, like our radio, our project now, they are changing. So the start here, it is colored with the black, and the end here, it is colored with blue or green. So Now the RF coils are okay and done. Okay, this one is the band selector. It appears new because we already have washed it with soap and water. Okay, I made sure that the contacts inside, they are all new, clean and new. All right, so we put some solution inside, and as you can see now, we have the confidence to put it to work. But we had to understand the configuration of the selector. Okay, you will see this is the volume control potentiometer, and it has a switch built in with it. Okay, it is shining because we already have washed it with water and soap, all right, and took out all the sticky dirt and wax from it. Okay, now it is operating in a good way, and we will be able to hopefully to reconnect it with better way. So you can see that we already have taken all these wires that were there because actually it's chaos. Okay, so you can see here we already have the configuration here on which we will depend to reconnect it again to the radio in a little bit accepted way. Of course, this capacitor here is 152 coded. Okay, it's a ceramic capacitor. It's for tone control. Okay, finally we've taken out all the capacitors from the radio. So all of them, they have lost some capacities of their capacity, right? And some others, they are already damaged. So we will change them all to guarantee accepted performance, good performance from the radio. We will change them with those new capacitors, okay? According to this picture here. As you can see, this one, the 1 microfarad, is totally damaged. This one here, the 33 microfarad, also damaged, needs to be replaced. All right. Also, this one, this is the 10 microfarads, and this one, 220 microfarads. They should be changed. That's why the sound was bad and there was some distortion, as you heard. Okay. But of course, to guarantee better results, we will change them all, because the others who are still working, they already have lost a lot of capacities that they have. Here we go. Everything has been reassembled, and it is time for test. But there is one final step should be done prior to the test, and that is to separate radio circuit from audio amplifier circuit and test each one alone. This is because we've actually recovered the whole radio and worked on both the radio circuit and the amplifier circuit. So, in order for the test to reflect the impact of our work, we should test the radio circuit alone by connecting it to an external amplifier, and to test the audio amplifier alone by applying an external audio signal to its input. If we were to test them all as one circuit, then we would not be able to notice whether our work has actually panned out or not. Also, if problems appeared, then we will not be able to decide where exactly the problem. Is it from the radio circuit or from the amplifier circuit by using this test? Then we will turn the radio. It's the 4.5 volts. Okay? Let's see. Now it is on. Okay. That's good. Seems to me this is the AM. Not yet. That's what you can see. Alright. Very good.
لو تبدأ حياة الإنسان
Very nice. Now we know for sure that the radio circuit is okay. It's working. No problem. Next is going to be testing the audio power amplifier alone. Here you will have to provide a signal provider. So bring any MP3 player or something and connect it here with this wire. That's what we are going to do right now. Okay, this is the schematic, and it is a little bit weird because this transformer goes to the negative, while in fact it should go to the positive. There is some arrangement that they have done. Alright, look at the speaker. It's coming from here. It should be from here with some feedback to the first transistor, but the second transistor is having negative feedback from the first transistor, or the opposite. So I think this is the problem. We have to solve it. Maybe we can provide a capacitor here. That's going to solve the problem, but it should be high capacity, like 470 microfarads. We will try and see.
You tell me where the trolley is. I'm wondering if there's a